Hi, I'm George Page, and our film this week takes us to a tiny atoll in the Pacific Ocean. Situated some 600 miles north of New Guinea and 1,600 miles east of the Philippines, it's part of the Caroline Islands group. Our atoll is hardly even a speck on the map, with a land area of only 49 square miles. But the lagoon there is of real importance in 20th century American history, a place that made headlines all over the world. And, as we'll see in our film, shot especially for nature by wildlife cameraman Wolfgang Baer, this is now a place of considerable importance to natural historians, too. A coral reef, nature's masterpiece of intricate design, created through eons of tireless effort by millions of tiny organisms, the reef provides the basis for an entire ecosystem, brilliant in color and complexity. Surely only nature's tireless hand could have built this structure. And yet, under the coral, behind the curtains of schooling fish, unnatural shapes appear. This reef is different. It's built on the skeletons left by another creature, man. Micronesia in the western Pacific is dotted with peaceful little atolls and lagoons. Smooth ocean breezes caress the palm trees overlooking the clear depths of the lagoon. In the quiet blue water, life goes on much as it has for thousands of years. In their day-to-day existence, the inhabitants of the lagoon and their surrounding reef are secure in their routines. But suddenly, the serenity is shattered by invaders from a completely different world. In the pre-dawn hours of February 16, 1944, a United States aircraft carrier task force launched a massive air attack against the Japanese naval base in Truk Lagoon. The enclosed waters of the lagoon provided the perfect strategic location for a forward supply depot for the Japanese fleet. Documented by U.S. Navy cameramen, 72 American fighter planes carried the first wave of Operation Hailstone to the Japanese base. Their mission, to bomb enemy airfields and eliminate fighter cover. While some of the American planes concentrated on destroying the land installations, others tangled head-on with Japanese planes. In some of the fiercest aerial combat of World War II, a Japanese plane fell burning into the ocean every 30 seconds. U.S. Navy Hellcats cleared the sky of enemy aircraft, leaving the lagoon virtually defenseless to additional attack. Over the next 2 days and nights, 30 more missions from the American carriers dropped nearly 500 tons of bombs on the desperate fleet of Japanese ships trapped in Truk Lagoon. Enclosed by coral reefs and completely without air cover, the ships were easy targets for the attacking planes. In the hell of exploding ordnance and burning fuel, 265 Japanese planes were destroyed and more than 75% of the land installations were demolished. More importantly, 60 Japanese vessels, some 200,000 tons of shipping, sank to the bottom of the once peaceful lagoon. The smoke cleared, and man went to other places to fight his war. In the hundreds of square miles within Truk Lagoon, the scars of the monumental battle started healing quickly as the inexorable forces of nature brought serenity once more to the lagoon and its numerous islands. But a closer examination reveals that things are not quite the same as they always were. Oil still bleeds to the surface as if from some gaping wound far below, even today staining the tranquil waters with reminders of a violent past. Truk is a graveyard of metal corpses. The twisted wreckage of the implements of war lies scattered around the 40-mile-wide lagoon. The ships, planes, cannons, and tanks from man's violent world create an eerie new landscape on the bottom of the ocean. Thousands died in the battle, and unimaginable numbers of the lagoon's creatures must have been killed. When the thunder and burning left Truk, the remaining marine life found their home changed. Once the short-term ill effects of the war passed, the plants and animals of the lagoon discovered the hidden blessings of the disaster. The debris created a substrate that had long been lacking in the lagoon. Until then, the inside of the lagoon had been an oceanic plain, consisting predominantly of a featureless sandy bottom that offered little or no shelter for marine life. Coral needs a stable ground on which to build. Substrate, as this basis is called, can be any solid object affording an anchoring point for the ocean's many life forms. The outer reef of Truk Lagoon had been formed eons ago by volcanic activity and had long provided a stable anchor for its coral reefs. But now, the lagoon itself has its own substrate. Because of the thousands of tons of ships and planes that sank into the lagoon, the available living space was vastly increased. The ocean took the first step in the adaptation of the new substrate to the needs of life in the lagoon. The salt water broke down the smooth painted surfaces of the ships, corroding and pitting the metal. Rust coated the once shiny surfaces, preparing them for what was to come. Life in the form of eggs, spores, and larvae floated in the lagoon in astonishing volumes and variety. The water carried a living, nutrient-rich broth that required only an anchoring point to grow and multiply. The shipwrecks provided that surface in abundance. Quickly, the wreckage changed from barren, burnt hulks to repositories of new life. Portions of the ships were in shallow water, and the brighter sunlight attracted algae and other plants that require photosynthesis, becoming luxurious pastures. And pastures draw grazers. Fish quickly found the new feeding grounds, and soon the underwater meadows were festooned with those searching for food. The nooks and crannies of the sunken ships provided perfect protection for young fish, and the complicated metal structures became nurseries and breeding grounds. As the numbers of fish in the new homes increased, the predators began to take notice, and their arrival completed the food chain. Thus, a new ecosystem quickly developed on the wreckage of war. More complicated forms of life took longer to establish themselves and grow. Filter-feeding animals called hydroids attached themselves to the new substrate, their fern-like fronds waving in the warm, gentle currents and thriving in the food-rich water flowing by. The soft pink coral looks like a strange undersea tree, but the coral polyps are little animals that stretch into the water in search of food. Sponges grew on the structures of a sunken ship near hard coral polyps, which have started turning this ship into a coral reef, creating even more living space for myriads of small tropical fish. A progression of color and life rapidly changed the dead hulks to a living community. At the bottom of the lagoon, a chain digs into the sand as if to anchor a vessel in place. The sun can barely reach this ground floor of the aquatic high-rise, and life is sparse. As we ascend, sponges encrust sea whips, competing for the same food and creating abstract patterns in the dark water. Rising over the bow, we can see the explosion of life on the ship's deck. Light, access to food, and available living space create an underwater garden. This bow gun is silent now, a home for assorted corals. The rich habitat attracts organisms of all kinds, carpeting what was once a warship. The sunken vessels increased the available living space in the lagoon, but in the most attractive areas, the inhabitants were soon literally living on top of each other. From a hoist that once supported a lifeboat, now hangs a cramped cluster of sponges, oysters, and soft coral. The wrecks became undersea penthouses, overflowing with occupants. A blue chromis seeks the safety offered by an encrusted cannon. Dashing in and out to grab bits of food, he stays close to his home and the barrel of the gun. Other fish prefer a crowd. Millions of these bait fish school together in the nooks and crannies of the ship's superstructure. Fish school for protection. The mass of life provides a confusing array for predators. Pressure-sensitive organs on the fish's sides sense the movement of neighboring fish. As if pooling their senses, the entire school moves in unison. An octopus enters the ship's bridge through an overgrown porthole. The ship is the Fujikawa Maru, which served as a transport for disassembled aircraft until it was caught by the American planes in 1944 and torpedoed to the bottom. The old cargo vessel became an island of undersea life in the middle of the lagoon. The octopus, or its ancestors, probably floated across the barren expanse of Truk as a larva until it happened upon the sunken ship. Now the shy, reclusive creature enjoys the dark confines of what was once the bustling nerve center of a ship at war. Before the war, the 435-foot, 7,000-ton Fujikawa Maru carried passengers and cargo across the Pacific. The Japanese Imperial Navy commandeered the ship in 1940, and now the octopus controls the bridge. Elsewhere on the bridge, these sausage-like sea cucumbers, relatives of the sea urchin, wave in a very rarely seen example of spawning behavior. They release eggs into the water like seeds into the wind, extending upright as far as possible, achieving maximum dispersion in the currents. At one time, the ship's bridge must have been a busy, confusing place. Now, the ocean has given it peace. Light shines softly through a Gorgonian coral as if through a lace embroidery. A closer look reveals millions of tiny polyps feeding on the nutrients in the lagoon. Behind the bridge, the main hold still gapes open, offering its cool, pellucid depths to any who care to venture within. In the hold, out of reach of the sun and predators, searching among the piles of machine gun ammunition for occasional bits of food, a lonely damselfish has the area all to itself. Deeper, in the ship's galley, the chef's equipment still lies scattered about, as if in readiness to prepare a meal. There's no food in the kitchen now, just silt and debris, but some small fish enjoy the dark sanctuary of the interior cabins. Back on the deck, a small anti-aircraft gun still points to the sky. At 140 feet, some light can still penetrate, giving life to algae and some sponges. The machines of war lie scattered on the deck. The wreckage of a small Japanese tank is barely recognizable. New life has covered its treads, and sea whips rise from the wreckage like antennae. A poisonous lionfish patrols the area as if on guard duty. Before the war, this passageway to the stern of the ship was perfect for a stroll in a cool sea breeze. Now the only breeze is the peaceful current of the lagoon. On the rear deck, a sea cucumber acts as cleanup crew. Like an aquatic street cleaner, it sucks up bits of algae from the sediment. Despite its efforts, though, the vessel will never be shipshape again. More than a foot of sediment coats the once polished metal surface. The sediment provides a home for a marine odd couple. The goby and the shrimp live together in a mutually beneficial relationship. The shrimp seems to carry more than his share of the load, as he continually tries to keep their home clean, while the goby gazes into the distance, watching for predators. Despite the multitudes of life in the lagoon, predators don't have it easy. Their prey have evolved many different and very effective means of defense. At twilight, the most dangerous time, the grazing fish search for cover. An old tire gives a giant anemone a home, and the anemone, in turn, provides shelter for the clever little clownfish. The clownfish coats itself with a layer of the mucus secreted by the tendrils of the anemone, which fools the anemone into not stinging the fish. The smaller clownfish are not necessarily young. In order to prevent overcrowding, a biological mechanism keeps the newer fish in the pecking order from growing until an older one dies. The anemone is far from harmless, however. Its tendrils, called nematoblasts, exude a paralytic poison into the unprotected fish and then carry the prey to the central mouth, where it's swallowed whole and digested. The clownfish wait by the mouth for waste products to be expelled. The clownfish pays its rent by cleaning unwanted debris from the anemone. Other species have discovered the clownfish's trick. The cleaner shrimp also lives in harmony with the anemone. Looking closely at the female's abdomen, the black eyes of many baby shrimp waiting to be born can be seen. Swimming near the underside of the anemone, domino fish also seek the protection afforded by the poisonous tendrils. But since they don't coat themselves with the mucus, they dare not venture too close. The shipwrecks of Truk Lagoon offer many private little corners for fish. This large pufferfish has found its home. The pufferfish's distinctive front teeth have grown together into a beak, enabling it to nibble at hard sponges. Today, the pufferfish leaves its niche and heads for the cleaning station. Each shipwreck has its own cleaning station, manned by cleaner fish, which are usually blue-streaked wrasse. The stations are always situated in prominent places, so customers can find them easily. The pufferfish swims up and hangs motionless in the water as the cleaners nibble away parasites, fungus, and unwanted debris. One little cleaner wrasse braves the pufferfish's mouth, and when done with his chores inside, emerges from the gill opening. The mast of the ship juts skyward and provides the top-of-the-line real estate. Plenty of light and more currents bringing food ensure that this prime area is well inhabited. Oysters, soft corals, leather corals, coral polyps, and sponges crowd into every available space and even grow atop one another. This is the culmination of nature's work on the artificial reef. Here are the most densely populated areas. At the very top of the mast, however, the wave motion is most pronounced, and the movement of the water keeps organisms from settling. The mast becomes barren, and then suddenly we're in the air, where the mast is nothing but a big piece of rusted steel. "7 million years ago, there was no Truk Lagoon. A hot spot beneath the ocean's floor broke through the Earth's crust and forced a swelling mass of magma toward the surface. A cone formed and grew and finally exploded into the sea. The massive eruption spewed huge amounts of molten lava and began to build an island. As the lava cooled and the island took form, coral began to take advantage of the substrate offered on the edge of the new land. The island slowly settled back into the ocean, and the coral built higher and higher, reaching for the surface. Eventually, only the highest portions of the island still rose above the sea, surrounded by a 40-mile-wide circular coral reef. Coral comes in a great variety of shapes, colors, and sizes, but actually consists of millions of tiny coral polyps, which create the massive reefs by secreting calcium carbonate as waste material. Each tiny polyp is an individual organism and has a symbiotic relationship with an infinitesimal plant called a zooxanthella. The plant requires light for photosynthesis, and the coral eats food drifting on the currents. So reef-building coral flourishes only where there is light, nutrients, and available substrate. Coral reefs extend all the way to the surface of the ocean. Here, the eroding action of the endless waves and the innumerable fish nibbling at the polyps create a ton of sand per acre of reef per day. The sand flows into the water, much of it settling into the lagoon, creating the sandy bottom. Life has evolved to survive in the deceptively featureless sand. Eyes peer up as if from the silt itself. The sole's excellent camouflage creates a hiding place in the sand. Other fish must excavate their homes on the flat bottom, using whatever tools they have at hand. In order to survive in the undersea dunes, the goby extracts food particles from mouthfuls of sand and ejects unwanted debris through its gills. Goatfish graze in this manner for whatever sustenance the sand may offer. The garden eel digs a tube-like hole and then floats upright in it, anchored only by its tail, searching the currents for food. They never leave the safety of their home. The garden eel is exceedingly timid, and when danger threatens, will disappear into the sand completely, reappearing only when the coast is clear. In the nearby sunken Japanese ships, the marine life continues to take advantage of the increased living space, changing the wreckage into environments full of life. Man has also learned to take advantage of this unique opportunity, and marine biologists have discovered the value of Truk Lagoon. Dr. Sylvia Earle began her studies of Truk Lagoon in 1975, drawn to the unique aspects of this man-made reef. A research biologist for the San Francisco-based California Academy of Science, Dr. Earl has spent more than 5,000 hours underwater, observing marine plants and animals. She has even lived for extended periods in submerged laboratories.
Truk Lagoon is a natural laboratory, a place where it's possible to measure growth rates of organisms and entire communities. The communities here began the instant that the ships reached the ocean floor. There's no way to tell the exact age of each individual, but none can be older than a date starting in February 1944. By observing a community of known age, some insight can be gained into how the diversity and structure of the ecosystem changes with time. This forest of small plants on the ship's deck has a counterpart on the seafloor below, but this stand is closer to the light, and thus the forest is somewhat more luxuriant than that on the seafloor in the darkness below. Numerous kinds of sponges are growing on the ship, most of them small, but this lovely large tube sponge is exceptional. Plankton-rich water is drawn through the numerous pores, and water is expelled out the main tube, minus most of the plankton. These conspicuous leather corals became firmly established on the deck of the ship and have held their place despite stiff competition from other would-be settlers. I observed this group flourishing for the first time in 1975 and will be fascinated to see if, through time, it is displaced by other species. Using the measuring device, the number of soft leather corals growing per unit area can be determined. When touched by a predator or even a benign biologist, the delicate polyps of the leather coral quickly retract. The size of this stony hard coral gives some idea of how large and well-shaped an individual can grow, given a fresh, clean place to start. This incredible showcase assortment of prominent coral reef species nearly obscures the ship's port rail. Sunlight and food are abundant here. The minimum growth rate for some species in such favored places proved to be as much as 2 inches a year, much faster than I had imagined possible. The interactions of natural history and human history are hauntingly present everywhere. Upon ships once engaged in war, there now are slow-motion battles for space between corals and sponges, oysters and algae, and among various kinds of coral. All are seeking a place to live and grow and reproduce their kind. Close-up inspection makes it clear that conflicts are continuing on a micro scale. Some win through chemistry, producing substances that are distasteful or toxic to close neighbors. Boundaries are established and silent retreats effected. Others, such as this luxuriant sea grape, win with speed. Through rapid growth, certain plant species may simply take over an area.
Dr. Earl's research has taken her to amazing depths in the world's oceans in search of knowledge about the many life forms that fill the sea. She feels that Truk Lagoon is one of the most important places for studying the complex ecosystems of the shallower waters. Just 100 feet below the surface, beneath the ominously looming bow of a sunken freighter, she finds an oceanic laboratory, rich in variety.
"8 years ago, I cleared this section of chain to bare metal to establish another point in time to begin measuring growth. Sponges, oysters, and numerous encrusting creatures have already become established. All available space is crowded with diverse life, one species growing on top of the other, forming an intricate, intertwining mass more than 2 feet in diameter.
Dr. Earle's studies are not confined to the heavily populated exteriors of the ships. Inside the wreckage are more secrets to be uncovered. The difference in the profusion of life is like day and night. With little or no light available, life is scarce, but still present inside the ships. Amid the artifacts of an earlier time, organisms like these tube worms crowding an old porthole find enough food to sustain their meager needs.
Entering the inside of a sunken ship is like exploring a cave with numerous passageways. It is dark, of course, and a bit eerie. It seemed reasonable to suppose that just as corals and sponges had adapted to the ships as reefs on the outside, so might cave-dwelling creatures be occupying the ship's dark interior. Red shrimp, such as this one, typically live in dark crevices and caverns. In the absence of light, the shrimp use their long, delicate antennae and other senses to find their way around. A few other small crustaceans and sponges, spiny oysters and such live here, apparently feeding mostly on detritus. It was fascinating to find that some creatures had adapted even the innermost reaches of the ship for their version of living space.
Sometimes a different perspective can complete a picture. Diving at night is a much more complex operation. Bigger lights can provide a better view of the life that blooms in the dark. But powerful electric lights need a generator and long connecting cords which can restrict a diver's movements. Dr. Earle follows the anchor rope down because the dark water gives her no reference points. Only when her light finds the brilliant coral can she venture afield.
Arriving at night, one finds the place transformed. Colors seem more intense. It's puzzling that so much color is present, but not revealed, until artificial lights are turned on. Soft corals and sponges that appear gray or blue by day become brilliant red in the full spectrum of our lights. Many creatures that are active by day rest at night. Some parrotfish actually spin a kind of transparent protective sleeping bag around themselves. This fish has chosen a quiet retreat between two tires. Some animals that are difficult to even find by day are conspicuously active at night. Filter feeders, such as this crinoid, feed on the abundant night-swimming plankton. A relative of starfish, many crinoids either live in darkness of the deep sea, or they emerge from crevices at night. Spawning oysters must synchronize the release of eggs and sperm to ensure that fertilization can take place mid-water. The potential number of young oysters from this one event is enormous. Only a few will ever grow to reproduce their kind. Most will join the hordes of other microorganisms that are eaten, and in turn will be eaten by something larger. Scattered or secluded by day, the small planktonic creatures flock to my handheld light and provide an unexpected, concentrated feast for this soft pink coral and this basket star. Through such interactions, the sunken ships of Truk Lagoon have become nearly complete ecosystems in their own right.
The plankton which so many inhabitants of the lagoon feed upon consists of untold numbers of various tiny organisms. A closer look reveals the intricate design of these minute creatures. Some, like the small medusa, a type of jellyfish, are no more than a few millimeters across, yet float through the water like a fleet of alien spacecraft. The debris of the Battle of Truk Lagoon brought new life to the creatures of the sea, but the heavy bombing on the land and the massive oil slicks that polluted the shores endangered the mangrove swamps which encircle many of the islands. It took years for the swamps to overcome this calamity, but today life abounds near the roots of the mangroves, a tree with the rare ability of living in salt water, as in our own Florida Everglades. At low tide, the mud is dotted with fiddler crabs, which now flourish in the once polluted swamp. The male fiddler brandishes his distinctive single red claw as a mating display and to intimidate other suitors. As two males try to outbluff one another, the plainer female looks on. If a fiddler crab loses his large claw, the smaller claw, which has handled the day-to-day chores, such as eating, will begin to grow and will soon replace the large one. Meanwhile, another small claw will grow where the large one had been. With the first drops of rain, the sensitive leaves of the mimosa close in preparation for a storm. The tropical islands surrounding Truk Lagoon are covered with lush forests. The heavy rainfall creates a thick carpet of verdant growth. The runoff carries soil to the shore where it's trapped by the filtering system of the mangrove tree roots. If the silt were allowed to flow into the lagoon, it would smother the coral community living there. The stands of mangrove create a muddy swamp, the perfect home for not only the fiddler crab, but also for the mud skipper. Living between the sea and the land, the mud skipper, seemingly half fish and half frog, but really a true fish and a member of the goby family, darts through the waters of the swamp, eating small bits of food in the silt. This is a face that only another goby or a marine biologist could love. The mud skipper's large eyes act as periscopes, enabling it to look in all directions above the water while submerged. On its two flippers that have nearly but not quite evolved into feet, the mud skipper scoots rapidly about the swamp. Its small dorsal fin stands erect as a mating display. Life has triumphed in the mangrove swamps amid the scars and wreckage of war. Today, Truk is a thriving seaside community. And a certain Japanese influence is still felt. The islands, part of a United States Trust territory, have a zip code and jet service from Guam and Hawaii to bring in the increasing tourist trade. The 20,000 citizens of the islands enjoy imported modern conveniences, luxury items from cigarettes to popsicles and donuts. But even as the new modern life takes hold, the old ways persevere. Truk's largest export is derived from coconuts, which grow so abundantly on the islands. By splitting the husk and then cracking the shell of the coconut, the meat can then be removed by hand and set out in the sun to dry. The product of this labor is copra, along with fish, a chief food source for the islanders. The processing of coconut into copra is a family project, and everyone joins in. It takes an islander a full day to harvest a bag of copra, which weighs 100 pounds and will sell for less than $10. As life continues from day to day on the Truk Islands, it's easy to forget World War II. Remnants of the Japanese occupation are scattered over the islands, but have become old, rusted relics, overgrown by the relentless jungle. Just as in the lagoon, the creatures of the land have learned to adapt man's destroyed tools of warfare into living space. The people of the islands have learned the same lesson. This was once the Japanese command post, a building so heavily fortified that it withstood 2 direct bomb hits with no apparent damage. Today, its steel roof and 3-foot-thick concrete walls house Micronesia's only inter-island high school. To these happy teenagers, the battle for Truk Lagoon is not even a memory. It's just a history lesson. One person who does remember the battle vividly is Kimio Isaac. He was only 17 years old when the American warplanes began their fiery bombardment. Kimio watched the entire battle from a safe hiding place on the island. He's the only eyewitness to the battle who still dives to the wrecks. Kimio sometimes serves as a guide to curious divers who wish to see the unique sights at the bottom of Truk Lagoon. But many times he will dive by himself, just to remember.
When I first went down to the wrecks, I kind of very, scared. Because I really don't know what's going on and what will happen and what I will meet. Then I explore some of the places, like a room, hatches, and I discover some of the things. Just kind of many things I discover.
The ships are full of artifacts and equipment. The whole lagoon has been declared an historic site. Danger lurks in the old hulls, and diving is only permitted with a licensed guide, such as Kimio. The many fascinating relics of life aboard these Japanese naval ships are all protected by law. They may not be removed from their watery graves. This particular ship sank upright, leaving its contents relatively undisturbed. Old bottles, cups, and saucers, and even phonograph records are still in the storage pens where their original owners left them. Deeper in the ship, completely shut off from daylight, this room, now covered with silt and inhabited by a few small fish, was once the ship's surgery. Fish live in the instrument sterilizer and swim over the operating table. The polished gleam of the room's fixtures can only be imagined now.
When I first went to dive out the ships, I really discovered the equipment they've been using during the war. I saw some of the cells too. The dead people on that one is, I would say, maybe some around 250 people dying on the ship. I do remember about that day when they attacked those ships and sunk them.
Kimio Isaac remembers the battle very well, and he remembers the people, some of them friends, who went down with the ships. He regularly makes a pilgrimage to the deep, quiet cemetery in the lagoon.
This is one of the very nice ships. She got in Truk 2 days before the attack. Ever since I always remember those days. I know some people on this one, and one of my friends was on this one. That's what make me always bring the flower to pay my respect to the dead on the sunken ships.
Truk Lagoon's shipwrecks are no longer just the barren, twisted relics of our own turbulent past. Overgrown with a million forms of life, they seem to welcome us with bright colors, teeming schools of fish, and dimly visible reminders that man created this reef in his own special way. In a few years, the shapes we recognize will no longer be apparent. The lagoon will have absorbed our history. The sea, as always, has the final word.